Hi, this is Alex from devstories.eu, Learning DSPy, episode 14 of 15. Every time you adopt a new AI framework, you typically end up rewriting the same custom Python wrappers for your database queries, web searches, and file readers. Instead of maintaining endless duplicate API wrappers, what if your agents could instantly plug into universal, standardized tool servers? That is the promise of the Model Context Protocol, and today we are looking at integrating tools with MCP. The Model Context Protocol is an open standard introduced by Anthropic. It provides a universal way to connect AI models to external data sources and tools. By adopting this standard, developers write a tool once, host it on an MCP server, and use it across any supporting framework. DSPy supports this natively. You do not need to write complex adapter classes to bring these external tools into your DSPy programs. A common misconception is that DSPy handles the underlying server connections to these tools itself. It does not. DSPy relies entirely on the official Python MCP package to manage the networking and establish the connection. DSPy only steps in at the very end to convert the active MCP tool object into a native DSPy tool format. To see how this works, let us walk through connecting a local tool server to a DSPy agent. First, you need an MCP server running. In your Python script, you import the server parameters class from the MCP package. If you are running a local process, you define standard I/O server parameters and point it to your server executable. Alternatively, if your tools live on a remote server, you configure an HTTP client connection. Both methods establish how your application will talk to the tool provider. Next, you use the MCP library to open a client session. Inside this session context, you initialize the connection. At this point, DSPy is still completely out of the picture. You ask the active MCP session to list its available tools. The server responds with a list of tool objects. Each object contains the tool name, a description of what it does, and the expected input arguments. Now you bridge the gap. This is where it gets interesting. For every tool returned by the server, you call the fromMCP tool method on the base DSPy tool class. You pass this method two specific arguments, the raw tool object and the active client session. This single command reads the schema provided by the MCP server and instantly wraps it in a compatible interface. You now have a ready-to-use list of native DSPy tools. Finally, you hand that newly converted list of tools to an agent. You initialize a React module and pass in your array of DSPy tools. When you run the agent, it can now seamlessly call the external MCP tools. The arguments flow from the React module through the converted DSPy wrapper over the MCP client session to the server, and the result flows back to inform the next reasoning step. The real power of this integration is decoupling. Your DSPy modules can securely access enterprise databases or local file systems with zero custom wrapper code, while ensuring the exact same tool server remains completely usable by entirely different frameworks. Thanks for listening. Happy coding, everyone.